Welcome. The purpose of this video is to help us as we prepare for our midterm exam. We'll take a look at material from each of the 5 units. One would begin with taking a look at the material from Unit 1. I'm going to share my video visualizer here, and we'll take a look at some problems. All right, there we go. Content from Unit 1, solving for the unknowns. This is the very first unit we considered in this particular course. Problem number 1 presents an equation for us to solve. Notice that we're going to take a look at distributive property. The 3 will multiply the x. It will also multiply the negative 3. It's a pretty clean look. 3x minus 9 equals 27. Add 9 to both sides. 3x to 36. Quick divide by 3, and you got the first problem finished at a clean division for x equals 12. We're off and running. Problem 2 asks us to solve a proportion, and the process for doing that is cross multiply. So on one diagonal, you're going to get 4 times x equals, on the other diagonal, 26 times 50. 26 times 50 with my trusty calculator is 1,300. And we're going to solve for x by simply dividing by 4. And again, a nice clean divide. X comes up 325. Problem 3, our first foray into word problems from Unit 1. Harry sells 2 particular items. He sells t-shirts and he also sells shorts. We know some content about those items. T-shirts cost $2 a pop. Shorts go for $6 a piece. We know that this particular month, those 2 items combined to sell for $600 worth of merchandise. And Harry also knows that he sold a total of 250 items. The key on this is to let one of the particular content sets be X. I chose to let X be the number of t-shirts sold. Could have just as well chosen X to be the number of shorts sold. It really doesn't matter. But the other one, in this case, the number of shorts for my solution, is 250 minus X. It represents the rest of the 250, knowing that X of them were consisted of t-shirts. To look at the equation, it basically is a dollar's drive. Each t-shirt costs $2. So the money for those is 2 times X, where X represents the number of t-shirts sold. In addition to that, you have $6 for each of the particular shorts, and the shorts for us were represented by 250 minus X, so it's 6 times that quantity. 250 minus X, there sits a distributive property for us. Distributing the 6 gets us to 6 times 250, that's where the 1,500 came from. 6 times negative X at negative 6X. Combining like terms, 2x and negative 6x gets you negative 4x. I went ahead and subtracted 1500, and that's how we got negative 900 over there on the right side. Another clean divide by negative 4, and x comes in at 225. Be careful on this, as many word problems, you're asked for both, how many shorts and how many t-shirts. Once you've solved for x here, we have the number of t-shirts sold, so 225. We'll use that value back in our original set, where you notice the number of shorts sold was 250 minus X. In this case, 250 minus 225 gets us 25 shorts for Harry's sale this month. That's our solution for problem 3. Problem 4. All right, 4 batches of chocolate chip cookies need 5.5 cups of sugar. The question says, how many cups of sugar would it take if we wanted to make 10 batches of cookies? It's a proportion problem. I set it up that way. The left side fraction represents 4 on top, and that's the number of batches of cookies that you could make with 5.5 cups of sugar. On the right side, you must be consistent on the right side of that proportion. The 10 on top represents batches, so we have batches on top of both fractions, and that would mean we keep cups of sugar on the bottom of both fractions. So 4 is to 5.5 as 10 is to x. Again, a cross multiply sets us in motion for our solution. One diagonal gets us 4x, and the other diagonal gets us 10 times 5.5. 10 times 5.5 at 55. This time not as pretty an answer as the previous ones. Divide by 4 to solve for x, coming in at 13.75. So to make those 10 batches of cookies, it would take 13.75 cups of sugar. All right, That takes care of 4. Let's flip it over and go for 5. 5 is one of those problems that has a lot of unknowns. We're going to talk about letter grades. Okay, and again, the thing on this problem is try to decide where the best place to start with X. And what I like to do is get to the bottom of the relationship stack if I can, and let that guy represent X. So if you read the problem, we know some things. We know that the number of B's is 4 times the number of D's. So it sounds to me like B's are based on D's. So if I just had that to deal with, I tend to say, let's let X represent the number of D's. Reading on, we're going to see if we can find out anybody who's at the bottom of that relationship stack. Right now, it seems like our best bet might be to let X be the number of D's. If you look at it, it says C's 5 more than D's. So again, C's are based on D's. So I think we're in pretty good shape if we let X represent the number of D's. We'll do one more check. It says there are 2 times as many A's as D's, or I'm sorry, A's as B's. B's, if you remember, were also based on D's. So I think we're going to be okay. Let's let X represent the number of D's. Now we'll take those verbiages about and try to represent the other letter grades. If you see the first one says the number of B's was 4 times the number of D's. All right, if we let X be the number of D's, then 4X would represent the number of B's. Read it critically. The number of C's, 5 more than the number of D's. So that's 5 plus X, or in this case, I think I prefer the X plus 5, although it doesn't matter. Either way would be good. Addition's commutative, so order doesn't matter. So the number of C's at X plus 5. And last but not least, problem says there were 2 times as many A's as B's. So if B's was 4X, 2 times that would be 8X. The equation is actually kind of easy to get to because you know there are a total of 75 students. So if we add all of those letter grade representations together, we got to get a total of 75. So there you see it on the right side. 8X plus 4X plus X plus 5 plus X, total of 75. Adding the X terms gets you 14X on combining terms, plus 5. Subtract 5 gets you the 70. And unlike last time, we get a pretty clean divide again. 14 divides 75 times. So X comes in at 5, and now we set back and use our setups to find out how many of each particular letter grade. X represented D's for us, so we now know that there are 5 D's. C's was X plus 5, so 5 plus 5 would be 10, so we'd have 10 C's. B's was 4 times X, when in this case that's 4 times 5, so we have 20 B's. And last but not least, 8 times 5 would be 40 as the number of A's. And if you wanted to check all the arithmetic, you certainly could add that and see that we get a total of 75. I'm going to leave that for you because I think we're in pretty good shape. And that, my friends, wraps the solutions to Unit 1. Here comes Unit 2. We'll play with percents. If you like to set it up in terms of the part and the percentage and the base, that's what you're going to see here. 20 represents the part. X represents what particular number, and 40% showing up as 0.40. So it's 20 is 0.40 times X. Solve for X by dividing both sides by 0.40, and X comes in at 50. So we have just realized that 40% of 50 would get us a total of 20. 20 is the part, 40 is the percent, and we were solving for the base. On problem 7, we can use the same setup. This time we're trying to find the percent. So we have the part and the base. The part is the 60, the 150 is the base. X represents the percent. To solve, we're going to divide both sides by 150. And we've got 60 over 150. You and your trusty calculator can punch some buttons, and you can get 0.40. And for us, that represents 40%. So we now have the answer we were looking for. 40% of 150 would be a total of 60. Moving to problem 8. All right, what are we looking for here? It looks like in this particular problem, we're looking for the part. We have the percentage. Now be careful, it's 180%. So as a decimal, that's 1.80. The base is 300. And we're going to solve for X by simply taking 300 times 1.80. Again, calculator manipulations. And you're going to set 540, and that would be the part. if you actually were to take 180% of a base of 300. 540 would be your answer. All right, last one on this page, number 9. All right, Bob bought 4 Dunlop tires at a local tire store. Salesperson told him that his mileage would increase by 8%. And be careful on that. If your original mileage was 100% of whatever it was, and that increases by 8, that makes you 108% of what you would have had previously. Previously, your Bob's miles were 24 mpgs, and we're looking at an increase of 8%. So if you want to do it in one step, it's 1.08 times 24, and that would mean his new mpg figures would be 25.92 if he goes and gets the new tires. I chose to do it in one step instead of finding out what 8% of 24 was and then adding it on to the 24, although that would have worked just as well. I think we'll draw a pause here at the end of problem number 9, and we'll catch you back on video 2 for the review for midterm exam.